Here we go, part B, Unit 2, Video 4, Part B, Restrictions. So here's where we left off from Part A, exact same place we left off. So once again, how do you check and see if two things are inverses of each other? Well, you graph the first thing, so here's the original, and this is no secret. I go left 1, I go down 3, I put a dot, and I sketch the graph, and it goes like this. And that's the original. Then I sketch the inverse. And I say, hey, what does this inverse look like? Well, I go left 3, down 1, and I'd start, there's one side of my parabola, here's the other side of my parabola, and as soon as I sketch that other side of the parabola, it ruins the vibe, okay? It's like when your little brother or little sister comes in when you're hanging out with your friends and you're like, oh, you're ruining the vibe. So, what do? Hey, you restrict. You're like, hey, brother, sister, don't come in the den. We're being cool in the den. We don't need your lame vibe, so we restrict you from going in the den. Well, guess what? We do the same thing with mathematical functions. We make restrictions. So here's why I wanted to do this video completely separate. You don't have to restrict cubes or cubic. Heck, if it's 5th power, 7th power, 9th power, you don't have to restrict any of those guys. Odd-powered stuff doesn't need restrictions because odd-powered stuff never does this weird thing where you got this extra chunk of information that ruins your y equals x split me down the middle vibe. You don't have that. So here's what we do. We go back and we say, you know what? I'm going to get my eraser here, and I'm going to say, get out of my face. If you were not there, then it would look good. That would be totally pretty, and that would follow the rule of visual inverse. So guess what we do? We say, you know what? All of the stuff that was on this side, I don't want to see it. I only want to see the stuff that was from here over. So we restrict and we say, x, you can only be greater than or equal to -3. Why -3? Why -3? Could I have picked a different? Nope. The restriction is x greater than or equal to -3. See, look at this graph. This is a parabolic graph. If you only show the stuff that is greater than or equal to -3, it would only be this part of the picture. And then the idea of y equals x, the idea of this guy splitting your picture right down the center is still valid. So you must include sometimes this thing right here where you say, I am restricting the function. And it's called a restriction. We only have to do this on even stuff. So if it's 2nd, 4th, 6th, 8th, 10th, square root, 4th root, 6th root, those guys need restrictions involved. But you know what? If you know how to do a square root, you would know how to do a 4th root. If you knew how to do a 6th root, you would know how to do, an 8th root. We're only going to do this. On your next, topic, or next assessment, I would only give you inverses that are y equals linear, like we did on the very first set. These are easy peasy. You go, no problem. I would give you y equals 3rd power or cube root. That's totally fair game for the test. And then now I'm about to go through what happens if it's like this, squared or square root. On your next unit assessment, those are the type of inverses you are responsible for knowing how to do. So let's do another one, because this was from my last thing. Let's just pick up, and let's make an example that looks just like that one. So you guys might want to actually pause the thing and see if you can do it, and then come back and check your work against mine. So here's the original problem I'm going to do. This is extremely similar. I changed the numbers and the signage to make it look a little different. And it's actually going to make the inverse picture look a little different. A little tiny change can mess with things big time. But maybe pause it. You try to find the inverse. You try to sketch the graph. Show me what it looks like. And then come back and check it. Okay, I'm assuming that you paused it and you came back. So here we go. I'm going to call this y equals square root of x minus 2 plus 4. I am then going to switch the x with the y. And I am going to solve for y. So I'm going to get this by itself. And I'm going to say x minus 4 equals the root of y minus 2. And then to get rid of a square root, I've got to square this. So I better square that. And then I'm going to say, hey, this means I have x minus 4 a la segunda is igual a, over here I got y minus 2. I'm going to add the 2. I'm going to add the 2. And then I'm going to say, cool, my new function is, well, I'm just going to cut to the chase. I'm going to substitute it back in and say, I'm going to call you f inverse now. F inverse equals x minus 4 quantity squared plus 2. So if I did find the inverse correctly, if I did, then I should be able to come over here and sketch this graph because I know how to sketch a parent function. I'm good. And I could sketch this guy first, this guy second. I could sketch y equals x last. But you know what? Just for kicks, just so you see, I'm going to sketch y equals x first. There's my y equals x. Now I'm going to get this top guy here. Now let's get him. So I'm going to say 2 to the right. And I'm going to say up 4. Okay. I would put a dot. And then I would say you are a square root function. So you're going to go like that. And then let's get this guy over here. Let's do this one. I'm going to go 4 to the right. I'm going to go up 2. And then I'm going to sketch my graph. But if I do this, and then I do the other side, whoop, that was really wobbly. Hang on, I'm going to undo that. And if I were to sketch in the other side, even if I sketched it pretty, it ruins the vibe. It totally ruins the look. Well, you don't want your little brother bugging you when you're hanging with your cool friends. So what do? You restrict. And you say, you know what? This is a fine inverse. This guy right here is a beautiful inverse. Me gusta mucho. The only problem is I only want to see from here over. I only want to see that much of that graph. So I would say x greater than or equal to 4. Why 4? Because that's where it is on the number line. And magically, that's what it is when you set it equal to 0. That's going to totally be a vibe we follow. Okay, I hope you took me up on it, paused it, tried it for yourself, etc. Look at how pretty that is. It's amazing. Okay? Let's take a look. I got more examples because second power can get a little bit icky. So I want to do a couple more examples. So the next one that I'm going to do here, let's see. That's not it. We did that one. Oh, yeah. Here we go. Sorry. I have my next example. Ooh, I scrolled down. I lost myself. Here we go. It looks like this. Y equals negative. Whoa, it's a negative. X plus 2 minus 1. There we go. That's what this guy looks like. Now, just so you get a vibe for this, some people like to do this while they work. And I don't care. It doesn't matter to me. They know that they have to graph y equals x. They know they have to do that. So they put that one in there and they go, okay, y equals x. And then they look at this one and they go, you know what? That means I go 2 to the left, down 1, and I top to bottom flip it. That means I go 2 to the left, down 1, and I top to bottom, flip it. That would be what that guy looks like. Now, I'm going to have to find its inverse, but I have a visual clue what I'm looking for when I get to the end. Maybe that will actually help me. Okay? Let's see what happens. So, I need to switch X and Y. I need to solve for Y. I will then have X plus 1 equals, there's a negative, there's a root, there's a Y plus 2, and then we've seen this already happen to us. Going to get the blue pen for me. Come on. Oh, there's a negative outside here. I got to get that thing out of my face. I got to divide both sides by -1. Get it out of there. I'm going to divide this by -1. I don't want to leave negatives in the bottom. It looks icky. So I'm going to run the negative through the top. You become negative, but I don't need anything in the bottom anymore. What's it equal then? It equals this. And it's time to square both sides. So I'm going to say, I'm going to square you. I am. You're getting squared. You're getting squared. So on the one side, I have y plus 2 now. On the other side, I've got this guy, -x minus 1 squared. I'm going to move this over, move it over, and then what do I have? Well, I have y all by itself. I have y all by itself. What's it equal? It equals, parentheses, -x minus 1 squared minus 2. Now, the negative is on the variable. That means it's going to flip it sideways. But you're going to see, let me just get you there. Remember, set what's in here equal to 0. If I set what's in here equal to 0, what would I need to plug in for x to make that true? Don't you dare say 1. It's -1. Think about it. If I wanted to set what's inside there equal to 0, I could add x to both sides. And then it would say 0 plus x, that's x. What's it equal? -1. Don't make a sign error, because then you're going to know you made a sign error, because it won't look right when you go to check your graph. So this goes left 1, down 2, left 1, down 2. I put a dot, but when I draw the graph, I do not want to draw this side. It'll look goofy. I want to draw this side. Oh, come on, really? It's not a line. I want to draw this side. Now, let's get rid of this piece that's not part of it. Take a look. That is indeed a mirror image about the line y equals x. It is. If I were to rotate that thing up and over there, I would still have the same exact picture. And you might be saying, well, wait a minute, what about the sideways flip? Wasn't that thing supposed to flip sideways? Well, here's the beauty of a parabola. If you take a parabola, I don't care where it is, over here, if I cut it down the middle and flip it over, it's going to look the same on either side. So when you flip a like a cubic graph sideways, it ends up looking like it does when you do top to bottom. These guys, if it's a parabolic function, you flip it sideways, it's still a mirror image of itself. It's a U shape. Now, let that kind of sink into your brain. Remember, the original problem was right here. And my inverse, just so you know, my inverse answer looked like this. When you guys finally do get to the assessment, part of my question is going to be find the inverse, totally. The other part of my question is going to be, can you hand sketch a graph for me based on your knowledge of parent functions, etc. So, let's see. I've got 2 more examples because I want to cover every single base that you could possibly run into in this stuff. So I got two more examples. So bear with me. Some of them are easier than others, that is true. I'm not trying to focus on the ones that I think you can do easily, because some of them you can do very easy. I'm focusing on the ones that I think are going to give you a problem. And the ones that I think are going to give you a problem are negative. Oh, and you know what? I forgot to do this. Oops, let me go back before I go any farther. We had to restrict this thing, right? We had to restrict this dude so that it would be a mirror image. So this would be x is anything less than or equal to -1. Let that sink in for a second. -1 right here, right here. That's what we set when we set this equal to 0. That was the number we got. And we want only this side of the picture showing. So you would restrict it so that you only see the part that is less than or equal to -1. I'm sorry, I forgot to restrict. That's the beauty of video. You can rewind it. So let's go down here. See this guy right here, this dude? This is the question. With the following restriction. With this as a restriction. See, if I start you off with a square root graph, when you get to the end, you restrict your answer. But if I started you off with a squared, I have to restrict it so that only one of your answers makes sense. What do you mean, one of my answers? Well, check this out. I'm going to start this one by drawing the picture. Come on, there we go. All right, and what the heck? I already know y equals x is going to come down the middle. So let's draw that in. There's my y equals x. And then I'm going to say, hey, this would be a parabolic function that goes 4 to the right. It would go 4 units to the right, that is for sure. But it would not go up or down from there. There is nothing else over here. There's nothing there. But it is flipped sideways or top to bottom. Think about it. Is it flipped sideways or top to bottom? The negative is not on the variable. The negative is on the parentheses, or the actual function. So this is a top to bottom flip. So this graph would go 4 to the right. There's my dot. And normally a parabolic graph would look like this. It would, totally. But this is the restriction. They're saying, you know what? We don't want you to graph both sides of this parabola. We only want you to graph the side that is greater than or equal to 4. So let's go back. I'm going to get rid of that and say, which side do I want? The side that's to the right of the dot or the side that's to the left of the dot? And the answer would be anything greater than or equal to 4 would be this stuff. It would be to the right of the dot. Why are you drawing it going down? Because this guy's making me go down. That's why. Okay, so here we go. Let's find its inverse. We already know what part of the picture looks like, but we have to figure out what goes over here. We don't know what goes over here yet. So let's go find that. What is that thing called? It's called the inverse. So I'm going to switch x and y. I'm going to switch x and y, but first I'm going to write it in y equals 4. So here we go. X equals negative y minus 4 squared. But I got to get this guy out of the way. I got to get this dude out of the way. I'm going to divide both sides by -1. That looks weird if I say x divided by -1. Why don't I just call that thing, you guessed it, negative x. I'll just say negative x equals, that's gone. And over here I got y minus 4, quantity squared. And then I'm going to root like a cheerleader. Over here I get y minus 4. Totally, what's it equal? It equals plus or minus square root of negative x. What? Plus or minus that. But I'm not even done. I got to move this over. So I get y, whoops, I get y equals plus or minus square root negative x plus 4. Wow. So let's examine this. This is the weird part about this. And this is when you start with a parabolic function with a when they start you with a restriction, that means you're going to have to make a choice here. You know how to sketch a graph. Do I sketch the positive version or the negative version of this graph to make it match up with my picture? So let's take a look. What does this tell me to do? It tells me to go 4 units up. 1, 2, 3, 4 units up. I do not go sideways. Now, normally, I am supposed to either sketch a graph that goes like this or like this. One of those two graphs is the guy. But wait, there's more. There's more. Ah, come on. There's a negative there. There's a negative there, folks, which means I am going to flip sideways. Now, when I flip sideways, so this guy flipped sideways would look like this. This guy flipped sideways would look like this. I have 4 different things there now, but only one of them is going to fulfill what this thing should look like. So let's get rid of stuff here. If it's sideways reflected, whoops, oh my God, I just undo. If it's sideways reflected, oh, I need my pen. Come on. It's either going to be this one or it's going to be this one. So, it's definitely not that, definitely not that. These were my guide arrows to help me draw it. So let's go through and say, you know what? If I get rid of this one, that would be the guy. What is the name of this function? What is the name of the dude that's finally left over all that work? His name would be G inverse, or her name, G inverse root x, or sorry, root negative x, let me undo that, root negative x plus 4. That would be the guy. That would be the name of the function that matches up with my function to make the inverse look correct. The concept is kind of abstract. The actual mathematics is not that bad, but you have to be able to visualize the graphs you're drawing. So, I didn't start this at the beginning, but I did start doing it later. Sometimes it's helpful to fill in this guy, graph the original problem, and then it helps you make a decision what your answer should look like. I got one more to go, but I know that you guys will have an AP Calc packet coming your way. So I do want to make sure when you hit the AP Calc packet, there's going to be a question on there that says, which of the following are functions? Okay, now here's the thing. I didn't want to get into the definition of this jazz or any of that stuff yet. I did not. I wanted to wait until I showed you how to do this and then kind of talk about it. Not everything in math is a function. Not everything in math is a function. Lines are functions. I could draw a line. Bam. Lines are functions. Parabolas are functions. Absolute values are functions. Circles, ellipses, ovals are not functions. See, here's the thing. Back in geometry, I don't know if you guys remember this, but they gave you something like this. X squared plus y squared equals 4. This was a circle with a center at the origin with a radius of 2 units. You could draw the circle. You go, there's the graph of my circle. A circle is not a function. It is what's called a relation. When two variables are related to each other, you can draw a graph. You can plug in numbers, you can get numbers out, you can draw a graph. But the thing is, any graph that you draw that fails the vertical line test is not a function. If you draw a graph like this, or like this oval right here, these guys fail the vertical line test. What does that mean? Let me get a different color. I'm going to get red. If I draw a vertical line through this line, I only hit it in one spot. I could do it over here. I only hit it in one spot. I draw a line through this absolute value. I only hit it in one spot. Draw a line through this parabola. I only hit it in one spot. I draw a line through this oval. It hits it twice. Circle hits it twice. If your drawing, if the graph you have can be hit more than one time by a vertical line, it's not a function. It's called a relation. Relations have no inverse. You cannot find the inverse of a relation. You can only find the inverse of a function. So, these guys, you can't find an inverse for them. You can't find an inverse for an ellipse, or what a lot of people just call ovals. You can't find the inverse for an oval, but you can find the inverse for stuff that passes the vertical line test. But when I did the cube root ones, look, when I do a cube, that's an x third problem, it passes the horizontal line test. It does. I can draw a horizontal line. It hits it only one spot. But here's the thing. How do you know when you need to restrict a function? How do you know when you need to restrict it? When it fails the horizontal line test. Look, I'm going to grab a different color, blue, what the heck. If I draw a horizontal line, whoops, oh god, that's horrible. Through this, it only hits it in one spot. Horizontal line, come on, hits it in one spot. Third power graphs, you never have to restrict anything odd powered. Third, 5, 7, 9, 11, whatever, you never have to restrict them, because they never fail the horizontal line test. But anything that is parabolic, you try to draw a horizontal line. All it has to do is ruin it just once. Up, hit it here, that's twice. If a function fails the horizontal line test, you have to restrict it. Now, depending on what they want you to match it up with, sometimes you restrict it so that you don't show this side of the graph. Sometimes you restrict it so you don't show that side of the graph. It all depends on the original question. But in the AP Calc Summer Packet, you will be asked, tell me whether or not the following things are functions. So can you tell somebody what's a function? Yes, it'll pass the vertical line test. These pass the vertical line test, meaning you draw it and it only hits the graph in one spot. Is something invertible? Can you have an inverse? Only if it is called a one-to-one function. A one-to-one function means it will pass the horizontal line test. See, if I draw, let me get this, and then this is why it's called one-to-one. This is the easy way to understand it. If I draw a horizontal line and I stop right there, I'd only hit this thing in one spot. But if I keep going, I'd hit it in two spots. If I want it to only hit it in one of these spots, I either have to tell you ignore this side of the problem or ignore this one, and then it'll be one time it'll hit my one graph. Why am I going through all this stuff? Number one, State of California wants me to tell you all this. And the second thing is, it's on your AP Calc Summer Packet. You better know what a function is. You better know what one-to-one means. And what is how do you find an inverse? Well, you find an inverse by switching x and y, solving again for y. That has never changed. Finding inverse is still the same. The only thing that's different is now you know that nonlinear inverses are more difficult. I got one last example, and this will be it. So here's my last example. It starts out like this. Y equals 2x squared minus 3. So the original problem is a parabolic graph. They started you off with a parabola. So if they start you off with a parabola, you know right away, hey, that thing is going to look like this. It's not 1-to-1. So which side of this graph do you want me to mess with? Here's the restriction. The restriction that was given on this problem says x less than or equal to 0. So what does that mean? Let's take a look at the picture. But before I do that, from Algebra 1, I waited to do this. I wanted to bring this up in this lesson. From Algebra 1, when they stick a number out in front, it will change how that graph looks slightly. Will that 2 in front of the x squared make this graph skinnier or wider? Will it make this graph skinnier or wider? And the answer is not wider. It is not. The answer is it'll make the graph skinnier. Numbers that are greater than 1, 2, 3, 7, 2,000 will make your parabolic graph skinnier. Numbers less than 1, 1/2, 3/5, 1/7. Those type of numbers make your graph wider. So, when I sketch this graph, just because I love to tie a bunch of stuff together, guess what? This is my HK formula, so let's fill in the blanks. This guy is my A value. This guy would be my K value. But what's up with this? Well, let's write it out. Just so you see this, A would be 2, x minus, there's nothing there, buddy, minus 3. I could write this thing in HK form. I could. What does it tell me? It says when you go to check me, I'm going to go down 3 units. And then I'm not going to go sideways. But when you sketch me, I'm going to be pretty... Oh, come on, really? When you sketch me, I'm going to be pretty darn skinny. I am totally going to be a pretty skinny graph. Oh, wait. I'm supposed to restrict it. Which side am I supposed to get rid of? The right side or the left side? They want me to only look at things that are less than or equal to 0. So I want to get rid of this side. Now I'm in business. Now I'm in business. Okay, am I asking you to write it in y equals a times x minus h squared plus k form? No, I'm not. I'm not asking that. So let's go back to the original. Let's find this guy's inverse. Because we can find the inverse of it because we restricted it so that the function is 1-to-1, right? I restricted it so it's 1-to-1, meaning this guy that I have left here that I left, if I drew a horizontal line, I only hit it in one spot, and that makes it 1-to-1. That means I can invert it. Let me get rid of that circle I just drew. Here we go. I'm going to switch x and y. And then I am going to solve again for y. So I'm going to move the 3. And I'm running out of room, so I'm going to go over here. And I'm going to say x plus 3 equals 2 times y squared. I'm going to divide by 2, divide by 2. And I end up with, I'm running out of room, so I'm going to move my work up here. I have a y squared all by itself now. I do. What's it equal on the other side? It equals x plus 3 divided by 2. So I'm going to cheerlead. Root. I will then have y equals plus or minus square root of all this stuff. Now, let's think about this. This is going to move my graph left 3 units. What is divided by 2 doing to it? Ugh. Well, don't panic. Don't worry too much. This could be rewritten like this. This could be rewritten like this. 1/2 times x plus 3. I could write it like that. So just like this 2 made my parabola skinnier, this is going to make my square root graph more relaxed. That's all it's going to do. You don't have to worry about it. I'm not going to be messing with scalar values that much. I just wanted to put one on the assignment and see if you got it right. That's really what I wanted to do. So let's do this. I'm going to draw my y equals x line in here. Whoop, oh my god, that was horrible. Please straighten up. There we go. So I got my y equals x. And then I'm going to take this guy, I'm going to go left 3. 1, 2, 3 units, put a dot, because it doesn't go up or down. Now, which picture should I draw? Should I draw the positive version of this? Or should I draw the negative version of this? Here's the positive one. That does not look symmetric to me. That looks really bad. So I would say you're probably not the choice I want. That's not good. So I'm going to get rid of that one. Oh, wait. I have to erase it. Get out of here. So let's draw in the other one. What would this version look like? Well, it would be to the left 3, and it would go down, but it would be a little more relaxed. Oh, God, that looks pretty, doesn't it? That looks pretty. That looks fantabulous, baby. That thing is beautiful. So, what do I want you to do? I wanted you to get to the end of this video before I showed you everything. Here we go. Here it is. Okay, see, this video is called Unit 2, Video 4, Part B, Nonlinear Inverses. Here's the homework. This is what I want you to try and do for me. Find the inverse for each of the following functions. Note the restrictions when provided. See, like number 1, I gave you a restriction. Number 6, I don't know, there's another one here. There's a couple, I gave you restrictions. You got to note those. Sketch the graph on the same coordinate system with the line y equals x to check your answer. Now, on some of these, you might have to restrict. I don't know. If I give you something and you find the inverse, you might have to provide like a little piece of information for me. So, I'm a big fan of checking work. I really am. So do yourself a favor. Try to do the first one. Then check. Here's mine. I did like minimal work, but I drew every single picture. So if your picture's not looking like mine, something's wrong with you. Until you get to number 4. So like here's the key. 1, 2, 3, and then 4. But even me, because I'm not an artist, number 4, the first time, the first time I tried to draw it, I screwed up so bad it looked so horrible I crossed it out. So there's the nice version of it. I had to take a little more time. But why was that one kind of a mess for me? Why did it look kind of tricky? Because it had a sideways flip. It had a, it had more action in it. So there's my answer key for 1 through 4. Here's my answer key for 5, 6, 7, and 8. Take a picture of it if you need to. And then 9 and 10. Here's my last 2, 9 and 10. All right. So guys, good luck to you on that. Yeah, good luck. End of the lesson. Bye-bye.